All right, Chapter 1, Design, Implementation, Management. This is kind of the overview of what we're looking at. A lot of this, for those of you that were in Oracle the last 8 weeks, is going to be very familiar. For you new folks, this will give you some little bit of a clue as to what goes on within the database system. By the way, I walk around a lot, so don't get worried. And if I walk out the door and don't come back within 10 minutes, class is over. So, all right, introduction. Good decisions require good information derived from raw facts. All right, that makes sense. Data is managed most efficiently when it's stored in a database. Well, yes, but it depends on how much data we're talking about. If we have 5 things that we have to keep information on or raw facts on, then maybe 5 index cards would work extremely well. However, if we want to take a look at 6 million census records, then we probably need a database to do it. By the way, I'm working right now to give you a new Oracle instance in vSphere that has that data already uploaded. And we think it would be better for me to do the machines and clone them instead of have you guys all try and upload the records. And my thought was, if I'm going to do it, that I'm going to try and get you 250 million. We'll see what happens. Ken's not crazy about that number because of the size. Data is managed most efficiently when stored in a database. Well, yeah, that's understandable. Data evolved from a computer file system. Well, yes, but before that, it actually was derived from a plain old file system. Think of a manila folder with sheets of paper in it. That's how we originally started with databases. All right. Databases solve many of the problems encountered in data management. That's correct, but garbage in, garbage out is very true. A slap-together database in Microsoft Access or the Apple derivative or some of the other databases that are out there is not a database. And we looked at that when we were going through Oracle. One of the key things it takes to make a good database is to have it designed properly and have it structured so the end user gets the data with total transparency, or gets the information, maybe is a better way to put it, with total transparency. So keep in mind, any 7th grader can sit down and create a database for us in Access or literally any other program, but you all have the key to doing that properly and correctly. And instead of garbage in, garbage out, we get data in and information out. And we're going to look at how we can do that. This is kind of a review from what we talked about in Oracle. Data's raw facts. We talk about information has to be meaningful and so on, but the key is what I've annotated down here at the bottom. Valid data equals valid information equals informed decisions. The bottom line from any database that you're going to design and is going to be used by a company is this option right here, informed decision. The database isn't designed for the individual that creates that database to play with and work with. It's really not designed how do I want to say this? It's designed so decisions can be made intelligently. All right? You're a programmer. You program a fantastic database, but if your end user can't figure out how to use it, then you've got garbage in, garbage out, because they can't make an informed decision. So one of the things we're going to look at when we talk about our project of the job bank is looking at how we can create a database that's going to allow those people at the Mid-Dell Food Pantry and Mid-Dell Success on how we can actually allow them to make informed decisions. Advantages of a database. It's the intermediary, it's the interface. The structure is stored as a collection of files. You can read this in the book. The key here is that users need to know that in every instance the data is absolutely accurate. Remember the database from hell that we looked at while we were in Oracle. One of the problems that happened because that thing crashed so often and then the data would get confused because it was such a poorly designed database is that eventually the end users quit using it because it wasn't accurate. They couldn't tell if it said that there was a part recorded in this database and it's out on the floor. You could go out on the floor and look and it wasn't there. And that happens a half a dozen times or so, and then people do not trust your database and they don't trust the quote information that comes out of it. So it's got to be accurate. You need to make sure that anything that you're putting into that database is going to come out exactly the way you want it. Again, you're going to hear me say several times this next 8 weeks, garbage in, garbage out. All right, so we control what's going in so we can get decision quality information out. This is a little diagram that's in the textbook that we want to talk a little bit about. This is the database structure. And we played a little bit with this in Oracle. We started to look at creating tables and table relationships. We're going to expand that in this 8 weeks in the advanced database. Notice here, we've got customers, invoices, and products, and metadata that tells us how each one of those instances is designed. But these are the key things in our database, all right, where we're putting the information. Notice on all of this, there's not one note or one instance where it says software engineer or software designer, okay? We don't design a database for us. We design it for these people right here. I highlighted this one because integrated view of data. Remember back to Oracle when we talked about the safest way to show data is by using a view. You don't need to show the end user everything that you're storing in your database. You only need to show them what they tell you they need to see. If they come and tell you, I need to see everything, the answer is, no, you don't. Let's talk about what you really need to see. These are not the bad guys, okay? Too many times, and I've seen it over in Tinker, and I saw it out at the FAA. Too many times, programmers think that the end user is a bad guy. Hey, if it wasn't for the end user, we program designers and engineers wouldn't have a job. Okay, so these are the people we have to work with. We cannot ignore them. Again, view, that's the best way to take a look at data. As we're going through this, if you have some questions, let me know. And if I can't answer them, I know Tom Duhan's number out at Boeing. I'll call him and ask him. All right, this is our database management system. In our case, we're going to work with Oracle. We could work with Microsoft SQL. We could work with IBM DB5 if we wanted to. I would prefer we don't work with Access. Access has some problems, and we'll talk about that, kind of refresh your memory a little bit later. Notice how this is set up, and this is really simplified. But what we're looking at is from the database management system, we have data going into the system. We have an application request coming out, and I think this is labeled wrong. This should be information. The data comes out, as we process it, it turns into information for our end users. All right? And it's our job to make sure that that information, again, is accurate. That would be a foot stomper. And of course, the key is the end user. All right? You've got to be able to address their needs and do it appropriately. When I was at Robbins-Joya, one of the things that I did when I was the site manager is I went around to every one of the organizations that used our product, and I sat down with them and I said, what's working? What's not working? What do our guys need to do to give you the good information that you need to make decisions on the production line? And one of the things we came up with was, well, the program that we're using right now, it was an old CPM program that managed the data, was not effective. It was too hard to get information out of. And so we actually spun that program into an online tool. And so the user could hit the web page. Oracle queries were already set up against the Oracle database. They'd hit that web page, and the data would be there within a second or two. All right, addressing the end user needs. Yeah, we still had some problems, but it worked extremely well. You got to keep that end user in mind. Single user databases support only one user at a time. Runs on a single desktop on a PC. I'm a little prejudiced because I knew Access back in the old days. But Access has never really been a good multi-user database. It's great for a standalone desktop single user. And here, defined single user is one person is on the Access database at a time, because it really doesn't have the software installed to handle multiple uses and the events that happen when two people sign on to the same record at exactly the same time. Now, Oracle is a good interface into Microsoft SQL. Works very well. I also saw somewhere over the break that MySQL actually was bought by Oracle, so I'm not quite sure where they're going. Oracle's not saying very much about that. These single user databases, if it's a true single user database and it's recording and reporting the correct data, they work exceptionally well. My wife's store, which she just closed after 27 years, she was the only one in management in the store that entered inventory and checked inventory out. So I set her up an Access database. It was ridiculous to try and teach her Oracle. Okay, Access, we could design a real easy front end for her. It didn't cost anything because it was delivered with Microsoft Office, and that's what we used. Okay, remember, a commercial version of Oracle starts around $8 grand and then goes from there if we want to use it. Again, single user database, they have their places, but if you're in an enterprise environment, if you're going to be in a multi-user, same time environment, then that's probably not the database for you. Data warehousing is something that we talked just a little bit about when we did Oracle, excuse me, but we want to go a bit further. Data warehousing is where you should store the data that isn't currently being used by your end users to make informed decisions. So let's say that we know our company cycle runs an 18-month cycle. And so we would run from January of 2014 to June of 2015. And we know that when we hit June of 2015, it's very, very unlikely that we're ever going to want to look at data actively from January of 2014. So we could put that January 2014 data in a data warehouse. It's out there. We don't daily work with it. It takes some special requirements to get into it, but it's still data that's out there, and it's still data that we can use if we need to. So data warehousing, again, for tactical or strategic decisions, long range. It's not the day-to-day operation of your business. This is a nifty little table that they have in Chapter 1. It talks about Microsoft Access. Notice it's got some footnotes under Microsoft SQL, under Oracle, under Microsoft Access. They do say Microsoft Access can be used in a multi-user environment. My experience has been, yeah, but you start to run into problems. So if that's all the company has that you're working for, then work with it and do the best you can. Hopefully we'll show you how to get out of most of the problems. This also talks about data location and data, what the heck is that? Data usage, how they do that. All things you can take a look at in Chapter 1. It's good information to know. When you go out and design a database, you're probably not going to have to worry a whole lot about it, because you're going to have a database engine that you're going to use, and they're going to tell you where to store it. All right. What do we want to say about this slide? Well, the first thing, poorly designed databases will get you in trouble. All right. There's a couple-step process that we're going to learn as we go through this. It involves normalization of the data. It involves integrity diagrams and relationships between data. And if you can keep those three things in mind as you work on a database, as you design the job database that we're going to design, you're going to do great. You'll get through the class without any problems. All right. Poorly designed databases, they'll get you in trouble every time you use them. What we are doing when we properly design a database is that we, the designers, are focusing on the structure. The end user doesn't need to know the tables that we're creating. They really don't need to know the attributes that are going into those tables, but what they need to know, or what we need to get from them, is what is the information you want to get out of this database. So I use my wife as an example. She wanted, one of the things she wanted to do with a sales database was to know what days of the month are people most likely to come in and buy certain items. And, you know, I thought she was really interested in how the database was going to be designed, so I sat down, I started drawing entity relation diagrams and talking about attributes and entity instances, and she's got this way she's developed over 45 years. Terry, just stop, okay? I did. I've learned, okay? I stopped, and she said, I want to see it on the screen. I don't care how you do it, but when I push a button, I want to know how many Beanie Babies we sold last month and what were the high days for Beanie Babies. I said, piece of cake. We can even do that in Access, all right? So we don't want to bug the end user or overwhelm the end user, if you will, with how we're actually going to design this database for them, this nifty, neat data to information tool. That's something we can keep secret, kind of keep it mystic. You learn to do that, and you learn the Oracle chant, and then you're good. You're golden. A little bit of evolution history. Computer file systems resembled manual systems in the beginning. And remember, in Oracle, we talked about the original database systems were what we called stream systems. I've worked with one. They are a real pain because you change the information in file number 3, and then that changes the location of every other file in that stream. And you have to be able to figure out how to go in and find out where all that file data is. But we took a filing cabinet and we kind of said, well, how are we going to make this into a computer? Well, we'll do it like we did with the filing cabinet. So that's how each system, the early systems, were developed. Now, one of the problems we got into with the early systems is that if I was in accounting, I would go out and I'd hire my own database guru, and that database guru would come in and he would design me a database for accounting. The guys over and gals over in marketing, well, they don't like my database guru. You know, he doesn't go to Buster's and drink beer with them after work. So what they do is they go out and they hire their own database guru. Now, the one in marketing might like Oracle, and the one in accounting might like IBM DB2 way back when. And so they each design their systems. And then personnel may have somebody else come in and work. And so the problem we got into is we had a flock of individual or department databases that couldn't talk to each other. If I'm using Oracle and I'm doing marketing and accounting is using IBM DB, and our two systems are not going to talk together. Well, in the old days, well, they still don't talk together well. All right. Along with that, we were creating copy upon copy of the same data. And what did we learn in Oracle when we enter data more than once? Audience participation.
Oh. Whoever entered the data last is the one that gets the information there.
No. Nice try, James. James was supposed to learn last 8 weeks that the more times we enter the same data, the more likely we are to have a mistake in that data. And once those mistakes get entered, then it's very difficult to tell what's the actual data and what's the false data. Again, all the way back to the first slide. We've got to have accuracy in our data. So if we've got 4 or 5 different databases that are designed by 4 or 5 different people that use 4 or 5 different database programs and can't talk together, we're going to have a problem. Okay? I can remember when my grandfather got his first bill from Ohio Edison that was handled by the computer, and it printed out. My grandfather only had a 6th grade education, technically, but he also was a lecturer at Ohio State in fire prevention, and he was a really fantastic fireman. Interesting guy. But I can remember he got that bill, and it was printed out by a computer. And for some reason, I was at their house, and he said, go out and get in a Chevy. And you never asked my grandfather why. Yes, sir, I'll do that. And because usually wherever we went, it was, one, educational, and second of all, we stopped at the Dairy Queen on the way home, okay? Do it. He went up to Ohio Edison, and I went in with him, and he was very polite. And he came up to the customer service desk, and he laid down his bill, and he said, please don't do this again. I'm educated. I can read handwriting. Because up until that point, all of the Ohio Edison bills were handwritten and hand addressed. Okay, so computer came out, printed the information out, upset Grandpa. They explained everything to him. They actually went back and showed him the computer, which was, I thought, was amazing. And I can remember him saying, you know, in 20 or 30 years, that machine might be worth something. And we did get the stock at the Dairy Queen. So. All right. In your book, in table 1.2, we talk about basic terminology. And please don't forget, I'll be interchangeable with it, But when we talk about fields, remember that's the same as talking about attributes. If you go to work in a real data center, they're more than likely going to start talking about attributes. So you want to know what those are. And then a record, remember, is also an entity instance. And if we look at the entire thing that we're designing, the table, shall we say, that is going to contain the attributes in each record or entity instance, that's actually called an entity. So attributes, entity instance, and entity. And we'll use those kind of interchangeably as we go forward. All right, this is just a picture that they had in the book with a little artwork by yours truly. And they're showing that here we have a sales file and a customer file, and here we have an agent file. And if things aren't put together, this is the example of a simple file system. There is no communication between the two databases, and then it becomes hard for this end user to talk to this end user, because what they may refer to as an agent file here and an agent, they may refer to something totally different over in the customer file. So from these simple file systems, we learned that we needed to consolidate everything, and we're pretty much still agreed upon that today. I love this quote. I use it every time I teach this class. Ubiquitous use of personal productivity tools can introduce the same problems as the old file system. Absolutely correct. When I was a commander over at Tinker, one of the problems that we had, and actually Ken Dewey helped me solve it, one of the problems that we had is every squadron had their own database. Every squadron kept track of their leave on a separate section. For those of you who have never been around or done the military, if I use terms that are confusing, ask me, I'll explain it. They kept their leave in a separate database. They kept their performance reports in a separate database. And the people making them were guys that were hobbyists. I mean, you know, back in the late 80s and early 90s, we still had a lot of hobbyists out there creating databases. And so what brought the problem to a head is we had one squadron. I used to be in it, the 965th, and they had put all of their leave forms and all of their leave requests on a piece of Microsoft Access, or on Microsoft Access. And the system blew up, and nobody knew who had been approved for leave, who had not been approved for leave, and they had some serious problems. The computer group went over and investigated, and we found out that the individual that created the program probably knew what he was doing, but would have done a much better job if he had done it on a legal copy of Microsoft Access, and not one he had bought in Saudi Arabia for 3 reals a disk and all the viruses you can throw on it. And that became a focal point, and actually Ken got us into networking things together at that point, and the rest is history, so to speak. But the military, DOD, FAA, government in general, a lot of businesses, they are almost death on personal productivity tools that you can't share, that you plug together, that aren't designed properly, and then you're trying to make corporate, responsible, informed decisions with. So these are things that you're going to see when you get out into the field. You guys going into, and gals going into cyber, if you haven't seen it already, there are some really atrocious databases out there that will screw networks up, that have absolutely no security at all, so somebody can literally walk in over the internet and steal vital corporate information, and the company will never even know it. I told you about the engineering firm downtown that had that happen to them before they were my client. Fortunately, that didn't happen while I worked with them. Microsoft Excel is another culprit that people think that Microsoft Excel is a database tool. No, it's not. Even though you can write some really cool macros to do a lot of neat stuff in Excel, it is not a database tool. Logical format, how users view the data. Physical format, how the computers must view the data. Don't confuse these, all right? We do not want our end users to even start to think about how the computer physically stores that data. It's going to confuse them. It'll probably upset them. We don't need to take them through that. And then they'll bug the heck out of you, all right? All we want to talk to the end user about is how we logically view that data and how we bring it forward. Data inconsistencies. This we saw in the database from hell. Data anomalies we get into where there's redundant data that might not be correct. There are ways in Oracle to go through and eliminate some of that data, but you're never 100% absolutely sure. And this is just going to get you into all kinds of trouble. So the key to all of this, again, is to sit down and do the work, plan it out, create the diagrams, do the normalization, write the data dictionary, and then create the database. I told you, I bet you every class last 8 weeks, more people want to sit down. I don't need no stinking design. I've got it in my head. I'm going to sit down and write the database right now, right here. Watch me. And they'll zip through it, and it'll run great until they're transferred or hit by a car or quit. All right? Think about Armstrong floor that we talked about in the last class. Most users lack the skill to properly design a database. Again, this gets really, really scary because you've got some middle school guy or gal that's had an introduction to computers, and in that introduction to computers, they talked about how you use Microsoft Access, and all of a sudden their parent thinks that Johnny or Janie is a super database person. They design a Microsoft Access database for the family business. 3 years later, when Johnny's more interested in girls than he is in databases, the database crashes, and what do the parents do? They have no idea how it was created. They have nobody to go to get the work done. So again, we want to leave this database design to the people that have some education in it. I would absolutely trust you guys once we get done with this class to design a database for me than I would a Harry High School, okay, quite frankly. And that's supposed to make you feel good, all right? You are more intelligent than the incoming freshman. Finally! Chris goes, yes, finally, finally. Okay, there are a lot of good definitions in there. Take a look at the book and breeze through them. Just get familiar with them. There's no reason for you guys to go to sleep and me get hoarse reading you what's in the book. But this is one of the things that you want to look at, okay? Let's see, what's this one? I got to get closer. Oh, again, this is just a reiteration of using a database management system to be able to know exactly what you're doing versus using a file system that will drive you absolutely nuts if you try and use it. All right, database components. Each one of these probably has a page and a half written in the textbook for it, but we want to talk about them just quickly. Hardware. When we start to look at hardware in a database system, you don't want to plan for what you need right now. It's probably what Ken has already talked to you about when you're trying to set up networking. What you want to do is plan for the future. In the military, when we designed a database system for Tinker, we designed it to run at 50% of capacity the first year that it was installed. All right, so we had 50% expansion in that computer system that we put together over the life of the system. All right, and then we would track every year what's our growth rate against our capacity, against our design format. And there were times when we would have to modify them. But in doing that, we knew we could predict when we needed to create either a new data function that was more efficient, or to go out and get new hardware that was more efficient or faster. Software tools. There's a variety of database systems out there that you can get. The big three, Microsoft SQL, Oracle, and database. Those are really the recognized big three. Oracle is the most prevalent that you're going to find in the military, in the government, and I believe in the oil and gas industry. And there's a very simple reason why. Anybody want to hazard a guess? Even though Oracle hates each and every one of us as end users, why is Oracle the system of choice?
Because it hates everyone?
Close. Or, go ahead, Chris.
Because it's got a lot of
sounds like
it's got a lot of system help.
a lot of system help. No.
No?
Remember the error codes we got in the Oracle class? That's not a lot of help.
I didn't mean like that, like call somebody.
Oh, call somebody. Okay, yeah, good point. The reason that Oracle is still in use as widespread as it is today is that the first real database system that could use multi-users was the Oracle system. And so originally, Department of Defense code, Oracle was more, personal opinion, Oracle aimed more at government and military. IBM aimed more at businesses. Okay, so we have all of these Oracle database systems that were designed back in the late 60s, early 70s, probably mid 70s, and they've run for 30 years. Okay, you come in and you say, I'm IBM, I want to convert your Oracle database to IBM, and we're going to charge you a lot less than IBM is. We did a test calculation. I can't tell you which division. We did a test calculation over at Tinker, and somebody wanted to change from Oracle to another database system. We were going to save $10,000 a month in going to this new system. However, it was going to cost us several $100 million to convert the database over to the new system. Guess what they decided to do? Keep Oracle. Oh, all right. So you'll find traditionally a lot of database in business, maybe IBM. You'll find Oracle out there too. Almost exclusively in all of the long-term military centers like Tinker, down at DoD at the Pentagon. A lot of their stuff is Oracle-based. And the reason is it's just too expensive to redo it or redesign it. Now, a lot of the new standalone stuff that we are bringing online isn't necessarily tied to that mindset. But Oracle's going to be around for a while. When I was computer group commander for AWACS, I got a little upset with the bill I got from Oracle. I think I was paying $250,000 a year for us to use Oracle. And then I found out the base was paying like $750,000 a year for their copies, and then Air Combat Command was paying a couple million for their copies, and DoD was, or no, Air Force was paying several million, and Department of Defense was paying several hundred million, so we could all use Oracle. Man, how do I get into that pot of money? What a deal. Because we were paying for something, my opinion was we were paying for something that had already been paid for. But just remember, Oracle hates you. It all works. All right?
Now I know why you believe Oracle hates us.
Yeah, been there, seen it. People, we've got two types of people that are in when we start to talk about database. We have database designers and we have the end users. All right, in the middle there, we've got, you might say, well, wait a minute, you got somebody that enters data into the system. That's an end user. We're not going to let a database entry guy go through and design our database system. But if you keep that in mind and you keep that, regardless of what anybody will tell you out in the field, if you as a database designer and programmer don't keep that end user in mind, you're going to be standing out on May Avenue with a sign, okay? We'll work for, what was the one I saw? The guy was out there being a comedian. We'll work for an internet connection. You know, whatever. Keep that in mind about the people that we have, and the book expands on that a little bit. Procedures, these can be written and these can also be computerized procedures. How do we manage this database? How do we work with it? How do we check and make sure that the data going in is always accurate? And then how do we make sure that the information coming out is of the quality that we want it to be for information to make decisions with? And then finally, we talk about the data, the key part of the system. And again, you'll hear throughout the book they talk about data integrity. We've got to have data integrity, or anything that we do with a database is worthless. Garbage in, garbage out. This one people forget, especially database designers. Most functions are transparent to the end user. You do not want the end user to input data and then press 3 or 4 buttons and check to make sure something has been entered properly, and then push another button on the screen, and then finally push enter to save the data. Or my favorite, press the save button to save the data. We can design a database that'll do all that data checking for them. If we design it properly, as people enter data into a field, we can tell within certain parameters if the data is correctly entered or not. Think about the census database that we looked at. And in many cases, I'm thinking of salary, household income. And instead of having to enter the income, remember they had a list, you know, 10,000 to 20,000, 20 to 30. The reason being it's a lot easier for somebody to type in a 1 for $10,000 to $30,000 and look on the screen and see it than it is for them to type in $15,736.23 and then go and check that and make sure that that's correct. All right? So we need almost all the functions that we're putting into our database systems to be totally transparent to the end user. And we can do so much for them. And when we get into PL SQL in about 3 weeks, you'll see that. Data dictionary should sound familiar, and what they do. And we're going to talk about data structures and dependencies a little bit later. This is Microsoft SQL's version of SQL Developer. All right. The key here is what it's showing us is metadata. And all that really is in a database is what's the attribute's name, what's the data type, and if it can be null or not. If it's not null, what's that give us? What might that lead us to believe? No, if it's checked as there always has to be a value there, what's the first thing you should think of? key. Very good. Everybody gets a gold star. See if I can find my gold stars and bring them in. This is a different variation. This is Oracle Lab, and we don't use that. It's not as much fun as SQL Developer. And quite frankly, you can't do as much with it. But again, what it's showing us is the database schema. And we talked a little bit about schema the last week of the Oracle class. But this is, again, showing us what the tables are, what the attributes are in the table, and so on. Security management. This is one that when we get into programs like Microsoft Access, there's not a lot of security there. And not necessarily security from people trying to break into your database, because you can encrypt an Access database if you want to. The security comes from the standpoint of what are the rules, how do we determine a user's access, and how do we determine what happens if Sandy and Charles both edit the same record at the same time and change the same attribute value to something different. What happens? Oracle has a way to sort that out. I've never seen it done in Microsoft SQL, but I'm sure they do, and I know I've seen it done in IBM DB. But that's one of the key rules to security. How do we handle joint use records? All right? And Oracle goes through and they look at what's the most, which was entered. Let's see, the first thing it looks at is the times that the data was entered. Then it goes and looks at the authority that each of the users has. And if based on that, if it can't decide, it'll throw a flag up on the screen. And it'll come up on Sandy's screen. Charles has changed the same data as you did. How do you want to handle it? And it'll come up on Charles's screen. Sandy changed the same data you did. How do you want to handle it? Oracle thinking that you two will get together somehow and decide who has the correct version of the data. All right. Again, standalone desktop databases don't have that capability. And when you try and force them to work on a network or force them to work in an environment where you have multi-users hitting the same entity instances, you're going to set yourself up for a problem. We found out in the database from hell that when two people had the same record open, and you would not think this would happen, changed some of the same data and hit the enter key roughly at the same time, the record disappeared. Not good, okay? Really, really makes for an impressive demonstration to an end user who's thinking about extending your contract. When you go in and you make the change in a demo in a conference room, and Joe Blow out on the floor just happened to open that same record, entered data in the same fields you did, and hit enter. What are the chances of that happening? Gets your end user's attention, but in the wrong way. Okay, this just goes on a little farther. Multi-user access control is what we're looking at, and also important, backup and recovery management. Key thing that we should have learned about Oracle, one of the keys is that once it's deleted, it's gone forever. You can't get it back. Too many times when we're looking at access backup, the only way to do that is if you physically take the responsibility to back that database up when it's done. And I'm here to tell you, I've used some Access databases. You do the backup, you read the instructions, you do exactly the way they tell you to do it. And then you say, okay, now, before we need to do this, I'm going to make sure I know what the heck I'm doing. And you're going to go through and you're going to say, okay, recover the database on this standalone computer from the backup. And the experience I had was 9 times out of 9 it failed. it did not restore the data. That made me really uncomfortable when I'm telling a client that, yeah, the contractors that I'm working for are making backups of your data every night. Then I had to stop short and say, but they probably won't work. You know, what do you do? Backup and recovery, okay. Yeah, I quit them anyway. Languages, oh, the key here, SQL is the common language. Slightly modified from what we learned in Oracle for Microsoft SQL or for IBM DB. But you've got the basics down. You had the basics in the SQL class. You can talk to a database. It's just finessing what the minor changes are as we go to. On top of that, PL SQL, which really lets you write some cool programs to go in and turn data into information, is an SQL-based language, just kind of on steroids. And so once you've got SQL down, you're going to be in good shape. Oh, we got to talk, this is almost the last slide. We got to talk about disadvantages of big databases. They increase costs, absolutely. You don't want to put Oracle in for a system that only one person is going to use, all right? You might not even want to put Oracle in for a small business. Oracle's going to charge you. Microsoft SQL is free when you set your network up. So that might be the way to go. Management is complex. We looked at, when we designed Oracle and Advanced Database, as to whether or not we wanted to include Oracle administration. And my comment was no. I'm not a half-bad Oracle designer, and I know how to manage a database, but I never want to be Oracle database administrator. I mean, you carry Tums in one pocket and Alka-Seltzer in the other. And you might get to go home Sunday night just to, you know, pack a new bag to come back to work. But when we get into a database system like Oracle, like the sophisticated SQL, like IBM DB, it's going to get complex. Maintaining currency is a problem. Oracle, in the last couple of years, has come out with a major database update every 12 to 14 months. And so if you're paying for that, and of course Oracle is never going to let you have it for free, if you're paying for that, then that means that in your budget, in tight times, you're going to have to plan to update your database. The problem when not doing it, well, we're going to save money this year. We're not going to update our database. Okay, so when you finally decide to update it in 2016, now you're 3 versions behind. Everything that you have is totally useless, and now you're going to have Oracle come in and do a conversion program for you, as an example. So you have to stay up with the currency, which adds a little more expense. It's dependent on the vendor. I mean, the Oracle company, in my opinion now, has Department of Defense right where they want them. It costs way too much to try and convert any of the programs that they have over to another database system. So what can Oracle do? Sponsor yachts, airplanes, you know. Vendor dependency. Once you get stuck on that, and it's not a bad thing. I mean, I can go anywhere in the Air Force and know how to access certain Oracle database programs and get my information out of it very quickly. The frequency of upgrades and replacement cycles. The good thing about Oracle, SQL, and IBM is that usually they test their stuff pretty well before they release it. And it comes out fairly solid. Okay, last slide for this hour, and this talks, you might take a look at it, Table 1-3. Most of you are cyber people, gamers and animators and so on in the front. But these are some of the different jobs that you can get into. A good Oracle developer going to work for the FAA, not somebody that's right out of school, but has a couple of years of experience. They'll probably start around $75,000 and move up from there, and a six-figure salary is not uncommon. A good software engineer at FAA will start around $95,000 and can go all the way up to about $250,000, depending on what they do. Okay, so good stuff. Whoa, what did I do? Okay. No, it's not too early to take a break. Take 15 minutes. Come back at 5 after, and we'll finish this up.
Alright, I tried enrolling. It wouldn't let me because it's past enrollment.
Okay, come in and see Steve. And,
Like today or?
well, he's gone